Good afternoon. It's a pleasure to be here today. I'll talk about AI factories and how they are redefining data center design as the next generation of digital infrastructure. Today, we are not talking about data centers. We are talking about AI factories. Why call them factories? Because they are the manufacturing of intelligence, the backbone of our digital ecosystem, using power, cooling, and compute as the raw materials. At Uptime, we have been studying this transformation worldwide, and we're working through how AI factories are redefining the design, power, compute of the digital infrastructure, taking into consideration data center reliability, high availability, operation sustainability, and tier compliance. Our survey showed a steady rise in direct cooling production. 60% of respondents reporting using a water cooled plant. 28% are using full immersion system, and 29% are using dielectric cold blades. What's even more interesting that the data center owners are widening now the allowable rack density with many sites supporting 40 kilowatts per rack. So, what's driving this change? The workload itself. Based on NVIDIA roadmap today, AI racks is in a range between 80 to 130 kilowatt rack, and they can be up to reach 600 kilowatt per rack and even reach to 1 megawatt per rack. The footprint stays the same, but the power and cooling increase tremendously on the infrastructure. This is not just a scaling, it's a complete redesign of the both electrical and mechanical ecosystem. And that redesign requires a shifting on the design, on the changing the design philosophy.
I'll see if they have
So, it's mean rethinking of space requirement, allocating more space for CDUs, bomb, and heat exchangers. It means reassessing floor loading and layout, ensuring that the structure can handle the heavy weight of immersion tanks, racks, and water line. Then come the fluid selections, choosing the right medium for performance, material compatibility, and long-term safety. Leak detection and containment. So deploying intelligent system that can be able to protect the IT assets before the leak causes the damage to those assets. And finally, to have a high availability and safeguard for AI workload. So you need to have a high available data center targeting a high tier level, tier 3 or tier 4, and both are achievable. Tier 3 for granting interval and tier 4 for tolerant, and both are achievable with proper design configurations. Let's visualize this with a reference design 60 megawatt DLC design. Here is the reference design, 15 and 60 megawatt tier 3 AI factory consists of 15 megawatt block. Each block consists of 5 megawatt data hall module. Each 5 mega data hall module uses ship water system in N+1 configuration. The key is modularity. Build fast, test fast, expand safely. In larger scale AI deployment, we typically see 5 to 8 megawatt data hall. In small scale AI deployment, we see that it is modular, so in a way that you can expand the data center without interrupting the live IT load. And here comes in action. Let's have a look at the chiller plant. Here, at the chiller plant level, we have the schedule plan the typical theory concurrent level configuration, distributed concurrent level configuration with bidirectional loop and a single part where each and every component part schedule can be removed from service without impacting the cooling to the critical AI workload. Now, let's see how it goes as CPU and rack level. And the CPU and rack level and the CDU and rack level, it's a typical also concurrent level configuration where we have a bidirectional loop with a single block that allow that each and every component at the primary side of the CPU as well as the secondary side of the CPU to be removed from the service without impacting or interrupting to the IT, to the AI workload. Now, let's see how inside the rapid cell. In the rapid cell, at the rapid cell, dual monitor connected to the IP assets with a thread-based quick connector. This will provide the ability to remove each manifold without impacting the cooling to the IP assets. Always keep in mind, your AI rack breathe coolant. Keep it clean, keep it flowing. Now, let's push the limit to see how we can comply with the Tier 4 requirement. Now we enter the Tier 4 world, where power and cooling must be fault tolerant. Here we are using distributed redundant configuration, which is 4 to make 3, or 5 to make 4, or 4 to make 3 configuration. This type of configuration will allow you to remove each and every cooling valve without interrupting the data center of the AI workload. Let's come to the second part of the Tier 4 requirements, compartmentalization. By adding, which is highlighted in red, by adding a couple of fields, which is highlighted in red, you can achieve the compartmentalization in a way that every single fault or fire in one single compartment, it will not propagate to the other redundant compartment, and it will protect your AI workload, and it will not have any impact in your AI workload. Now, let's have a look at the schedule plan where it is complied with Tier 4. Here, in the schedule plan, we have the distributed redundant 4 to make 3. Each core power stream or each core power cooling stream is totally independent from the another. That means you can isolate each and every and have a fault, even a leak fault, because it's Tier 4 at the end of the day. Fault in one single schedule and binding system without impacting the cooling to the AI workload. That means you will have continuous cooling to the AI workload, even if there is any single fault due to leak in any of the shield water pipe. In addition to that, there are a set of motorized bars where it is autonomously act in case of a leak. In case if there is any leak, those bars will detect and will isolate and close and sustain the AI workload. Now let's have a look at the CDU. Similar configuration as we did in the schedule plan theory, where we have distributed redundant configuration. So as you can see, you have 4 bath, bath A, bath B, bath C, bath D, which is 4 to make 3. Any fault or leak in any of the primary side of the CPU or the secondary side of the CPU and the tertiary side, it will not impact the cooling to your AI workload. Remember, the purpose is to first sustain the AI workload and to protect the valuable IT equipment, because a single leak or a major leak could really damage and damage the IT equipment, the AI equipment, which is worth millions. Another configuration where we have n plus n. So again, in uptime, our tier topology is performance uptime. That means you can achieve the tier level with multiple ways, with multiple design. There is no one straightforward one design. There is multiple ways to achieve our design. So it's a performance outcome. So another way of achieving tier 4 is to have n plus n configurations with separate and independent header. In case that you have a leak in any of the header, it will act independently. It will, the leak will be isolated automatically, and there will be no impact on your AI workload. Your AI workload will keep running as normal. Now, let's have a look inside the rackets. So, in tier 3, we have a dual manifold where the dripless connector connected to the IT's assets. Now, what we have in addition to that to achieve tier 4 is to have a solenoid valve. The solenoid valve, the purpose of the solenoid valve is to detect the leak, isolate the leak, and sustain the operation of the AI workload, and most importantly, is to protect the IT asset. Can you imagine what is the amount of water or flow in 130 kilowatt rack or 600 kilowatt rack? It's a huge. A leak happened in that manifold can flood the whole data center and can also damage the IT assets. So you need a kind of automation system which protects your IT assets and at the same time sustain your AI workload. That level of reflex and intelligence you need to provide to protect your high-value IT infrastructure. Now, let's talk about how we behave in this world. AI workload are highly unpredictable. A single training cycle can surge from 30% to 100% in just a few seconds, which is create as challenges on the UPSs and the engine generators. If those transient propagate from the IT racks, AI racks, up to the engine generators, for sure it will impact the engine generators, and for sure it will impact the grid stability. Because again, you can imagine 100 megawatt AI factory or 60 megawatt AI factory. Then you have the transient between 30% to 100% in a few seconds. This will cause challenges for the UPS because the UPS cannot handle such the current UPS, let's say, the current UPS, traditional UPS, the traditional data center, cannot handle such transit as well as the engine generators. So the key here to absorb and to filter those fluctuations at the UPS level. So to preventing those transients to propagate to the engine generators, to protect the engine generator, as well as to make sure that there is no impact on the grid stability. But we can't just design it. We have to prove it works. And that's where the commission come in. So, as they say, design are just promises until they are tested and proved reliable. That's why we have the 5 levels of commissioning are so crucial. Each commissioning stage is validate your different layer of levels, starting from the component level up to the IST test and final facility test, which we call it TCC. During the final facility testing, AI workload study transient, which is from 30% to 100%, need to be simulated with the use of special load banks to make sure that you tested your critical capacity component, to make sure that you tested your UPSs, to make sure that you tested your engine generators, that be able and capable to handle this AI workload. When the facility passes the final facility testing under those stress conditions, this is when you can say that your facility, the AI factory, is ready for the AI workload at the maximum demanding and the worst case demanding AI condition. So imagine if you have a data center and you have wrongly selected the UPS or wrongly selected the engine generator that is not able to take AI workload. Guess what? When your AI workload is running, those engine generator will fail and your facility will be out of service. So you need to make sure at the design stage to select the right type of equipment that's capable to handle this AI workload model and to make sure that during testing commission to have the full load by using the special load band to simulate this AI load transient to make sure that your facility is ready to receive the AI workload. And finally, this needs to be preserved in operation. Once the AI factory is operational, this is the real work begins. New challenges will arise, from technician skill level to operational discipline. The mechanical technician role now is extended up to the rack level, managing system with $1 million. That's why you have to have a qualified and skilled technician that be able to work and deal with those AI labs. Again, before the mechanical technician were limited to the gray space area, as my colleague said before. It was gray space area and white space area. The technician is limited to the gray space area. He's not entering the white space area. But now you have a mechanical technician who reaching up to the rack level to connect the dribless connector to your IT assets, to make sure that your IT assets is receiving the right coolant. So having a skilled technician is become really cool. Today's operator must be fluent in both mechanical and IT metrics. Before, operators were only focusing on the mechanical system or IT system. There was no operator who was fixing both. So bridging the two worlds that used to be separate, it's a must at this stage. When you have the operation is extended up to the IT level. Previously, there was operation team managing only the white space, and operation team managing the gray space. Now you have your team, the operation team is managing up to the IT level. At the Uptime Institute, we focus on operational sustainability, ensuring that original design, operational and management behavior sustain the AI workload through the facility lifecycle. Let me close with this thought. AI factories are not just the next stage of infrastructure. They are the backbone of digital intelligence. Our mission is not only to power them, but to make sure we keep them reliable, efficient, and operational. Thank you very much.